Okay, hi everyone. Today we are working on synthetic division. We're going to review how is that similar to regular division and why do we even have synthetic division. Again, this is an algebra 2 skill that your teachers might have covered, but we're going to do one more step. We're going to apply this synthetic division rule. Okay, so first thing, let's look at a simple problem. And a simple problem is going to be x, let's switch color here. Sorry, someone just came in. Adrian. Okay, switch colors. Switch to a blue, a nice pretty blue. Let's use black today. Here we go. All right, sorry about wasting your time. So we're going to do a polynomial division, but using synthetic division. Synthetic division. That's the H here. Synthetic division. Okay. Synthetic division. Right. So let's go look at regular division, and we'll look at synthetic division, and we'll see how similar they are and how different they are. So let's do long division first. So if I give you the problem x squared plus 6x plus 8, and I ask you guys to divide out x plus 2. Okay. So we worked on this on our last Excel work, our last homework. We do 3 steps. 1, we match. 2, we multiply. And then 3, we subtract. Okay, so we're going to do those 3 steps. We're going to match. We match x times what is x squared? X times x. That's our matching. We multiply downward. We multiply the binomial here, everyone, by x. So x times x and x times 2 is x squared plus 2x. And then we subtract. Do a parentheses, and we subtract. Here we go. We end up with 0 plus negative, 0 plus 4x. You don't have to write the 0, right? We usually leave it blank. So 4x. Then we repeat the water cycle. We first try to match. How can I match x and 4x? We need a 4 there, so a positive 4. Then we multiply. Let me bring that down. Bring it down. 4 times x is 4x. And 4 times 2 is 8. We can see that these match perfectly, and we're going to subtract, and that gives us a 0 remainder. All right. So our answer is x plus 4. That's our answer right here. Now, synthetic division is going to do all the same steps except faster. And the reason why it's faster is because we stop writing certain things. Now, let's go ahead and talk about the setup for synthetic division. In synthetic division, we're still trying to divide x squared plus 6x plus 8 divided by x plus 2. We are still trying to divide these out. Let me draw these parentheses so you can see that. Except I'm going to change this a little bit, and we do a setup. Instead of drawing a division sign like this, we're actually going to flip it around. I'm going to flip it around. And we're going to have 2 levels here. Just be careful, we're going to have 2 levels. Okay, 2 levels going on. The first level is just writing the front coefficients. Just write the front number is a 1. The second number is going to be a 6. And the third number will be a 8. I will only write plus or minus. I'll only write minus if it is negative. If it's positive, just leave it as positive. That's our default position. Okay. Hopefully you guys can see it. I wrote 1, 6, 8. If there's more terms, I would have written more things. The next thing I want to make sure you guys understand is that in synthetic division, I don't write any of the x's because they're redundant. Instead, I'm going to think of this as placeholders. So the first spot is going to be the largest x, x squared. Second is going to be x, and third one is going to be a constant. So these are actually placeholders rather than me writing the variable and coefficient. Instead of writing x squared, I'm just going to write 1 because that's 1 in the x squared position. I have 6 in the x position, and I have 8 in the constant position. Okay. Then the next thing I do, which is a little different than what the book does, I will write this. I'm going to write my term I'm trying to divide by, x plus 2. I'm going to write that right on the bottom. Remember we said there's 2 levels here. Now, I'm going to ask you this question. What number cancels out this x plus 2. What number would make this go to 0? What x value would make this go to 0? The answer is if x was negative 2. And our goal is to write down, again, the number that would make this go to 0. In this case, negative 2. So this is the number we're going to use. This is our key in synthetic division. We're going to multiply every number by this. All right, here we go. So now we're going to get into synthetic division. We're going to follow a step. So please follow along for the ride. And the ride goes, we're going to start filling out some numbers here, some gaps here. We're going to fill out all these gaps here. And here's what the rhythm is. So make sure you see the rhythm. First step is free. Always bring the first one down. And that's going to be a 1 here. Then we're going to multiply up. Multiply up. What's 1 times the key? 1 times negative 2 is negative 2. We're going to add down. 6 minus 2 is 4. We're going to multiply back up. 4 times negative 2 is negative 8. And we're going to add down to become 0. I'm going to draw a box around the last number. Now, this looks like just a bunch of numbers, but we are actually done. To go from x squared dividing an x, we have x plus 4 left. We drop an x value. So this is now the x position, and that's the constant position. X plus 4. Take a look. This is our same answer here. It seems overly complicated. It seems like it's a lot of steps. Why don't I just do long division? Now, I want you guys to notice a couple of things with this. First thing is that all the numbers we wrote here, we actually wrote here, but in a condensed smoothie form. Right? So let me show you this. Let me point out some stuff. So let me use just a couple different colors here. So you see this negative 2 here? Oh, that's a little too dark. Let me make it a little more opaque. Okay, see this negative 2? That's as negative 2. See the negative 8? That's as negative 8. Our final answer is 1 and 4. We have 1 and 4. So synthetic division is really long division. And let's go through another example before I elaborate on that one more time. So let's do a larger problem here. Let's do a larger, let's do a larger problem, a little longer problem. No, this isn't going to work out. Let's see. Okay, give me one moment while I give you guys a problem. Okay, so that's the basic mechanics. Let's go through our next problem. This is going to be a little longer, okay? It's going to be x cubed plus 4x squared minus 11x minus 30. All right? And we're going to divide x plus 5 from this problem. All right? Now, to do long division, this would have been a huge cycle. It would be even longer. All right? But I'm going to squeeze this all into one simple 2-row problem. 2 rows and we're done. Okay? Synthetic sugar, synthetic meat, synthetic, I don't know, everything. But let's go ahead and set this up. We draw our upside down division sign. Everyone please draw the upside down division sign. And then we're going to copy just the numbers in. So we're going to write 1, 4, negative 11, and negative 30. This is the setup for our synthetic division. Let's double check. This is x cubed. Drop 1. X squared. X and constant. Remember, we have to have all these terms, all these values, because synthetic division is a little blind here. It just looks at the position. It doesn't really care about what terms you have. It just cares that you have those positions correct. I'm going to write x plus 5 on the bottom. Okay, that's my factor I'm dividing out. But what is the value? What's the key? What makes x plus 5 go to 0? That is going to be negative 5. Okay, that's going to be our all-star right there. Okay, so the flow goes down, up, down, up, down, up, down. Done. Okay, that's the flow. So the first one is we always bring down the first one free because there's nothing to add. 1 plus 0 is 1. We always multiply up. What are you multiplying? You're always multiplying by the key. You're always multiplying the key by all the numbers on the bottom. So 1 times -5 is -5. Always add down. You always add down, and we multiply up. Add down, multiply up. 4 minus 5 is -1. Multiply up to become a positive 5. -11 plus 5 is -6. Multiply to go back up. Add down, multiply up. We end up with positive 30. And -30 plus 30 is 0. Winner, winner, chicken dinner. Our goal is to get a 0 at the end, and that's super important for what we'll talk about a little bit later. But our goal isn't to just factor. Our goal is to just divide. Okay, that's the goal of this whole homework, just to divide. Okay, what do we have left over? So let's rewrite this in positions. We have x cubed, x squared, x, and constant. We drop one exponent, right? We drop one exponent because we divided an x. We now have a 1x squared. You can write a 1 here if you want. Minus 1x minus 6. Now, if I was doing long division, I would have to write so much more than this. So I'm just going to try this on the right side here so you guys can just see it. If I was doing long division, x cubed plus 4x squared minus 11x minus 30, we would have to match, multiply, and then subtract. Then we would follow again with match, multiply, and then subtract. And then match, multiply, and then subtract. So if you look at this, this is just pretty much 2 lines of work versus multiple lines of work. And no matter how long this is going to be, synthetic division is always just 2 lines of work. Now, I want to take note, as we mentioned before, there are certain key elements that are repeating. First thing, I want to make you guys notice this. Do you see how we're always just subtracting these terms? It's a little bit redundant, isn't it? It's a little bit redundant. And the next term, don't we just bring down that next value coming down? Hey, we wrote it up here. Why are you rewriting it down here? It's a little bit redundant, isn't it? Again, being a little bit redundant. Now, I wanted to show you the stuff that I didn't highlight. Look at these numbers that I didn't highlight that are left over. Oops, sorry about that. Look at these numbers that I didn't highlight. Okay, I'm going to highlight these in blue now. I didn't touch this guy, or this guy. And these are my numbers here. The -5x, the -5, no, the +5, and the +30. What happens is synthetic division is taking long division and saying, you know what, there's a lot of redundancy there. A lot of stuff that's, I'm just rewriting it for the sake of rewriting it in long division. Why don't I just worry about the important parts? And if you will see, do you see how this is 4 minus 5? Isn't this 4 minus 5? In this 11 plus 5, isn't this 11 plus 5? In this -30 plus 30, -30 plus 30, it just took the important parts. That's why synthetic division is faster. I'm not worried about rewriting x cubed, x cubed, x squared, x squared, x, 6x, 6x. I'm just worried about the important parts in the back, which is kind of cool. Whoever thought of this is some type of genius, I'm telling you that. Okay, again, look at this. This is 4 minus 5, 4 minus 5. -11 minus 5, -11 minus 5. -30 plus 30, -30 plus 30. All right, we just took the important parts, and that's synthetic division for us. Remember how we were multiplying up? Let me show you what we did here. We used to multiply up, right? Match, multiply. We multiply, right? we are multiplying up by this number here. Right? You see this negative 5, this positive 5? The only important part is this negative 5. So we just multiply them all by 5. That's how we end up with synthetic division. A little bit messy, but you can see all the important parts in long division are in synthetic division. Okay. Let's do one more example here. Okay, let's do one more example of long division. And it's going to be x cubed plus 11x squared plus 38x plus 40. And we're going to divide. In this case, we're going to divide x plus 5 by this problem. Okay, if you want, you can do long division. It's going to take us forever, but synthetic division is the future. It's the future. So we draw the upside down L. Oh, sorry, just an L. Okay, and we're going to fit everything into it. Now, please go ahead for yourself. Go ahead and fill out the 3 coefficients, so 4 coefficients here, and fill out this part on the bottom. I'll give you guys 5 seconds to do that. Remember, you are not writing any of the variables for this part here. What's the term I'm trying to divide? That's going to be x plus 5. That's important for us so we can see what factor I'm dealing with. What is my key though? What is the key? How do I cancel out this plus 5 again? We're going to do a minus 5. All right, so I want you guys to see if you guys can get through the end. See if you can get a 0 at the end. Winner, winner, chicken dinner. Okay, first one's free, okay? First one's free on me. First one's always free on me because we always add down. Okay, adding down 1. Hopefully you guys are ahead of me. Hopefully you guys are done. Minus 5. 6. Minus 30. 8. Minus 40. And we're done. Winner, winner. Let's rewrite this. What's left over is we're going from x cubed, divide the x, so dropping 1 step. So we're left with 1x squared plus 6x plus 8. Okay, so if you guys feel you guys are comfortable with this, can you guys give me a click yes on the participants? And if you're still a little confused, put no. But if you want me, so yes or no, okay? Let's do that, yes or no. Okay. All right, we see about a third of you guys, a fourth of you guys actually, a fourth of you guys responded. Thank you for those of you guys who are responding. Oh, that's terrible. That's my response. All right, so let's go ahead and look at what your homework looks like today. Very similar to this. So we're going to take this problem here and we're going to be asked to do synthetic division to it. Now, for this problem, it's going to be pretty easy. This one I think will divide out. So let's go ahead and do that. So we're going to set up our synthetic division. Copying these values pretty quickly. It'll be 1, 12, and 27. These are all positive, yes? In the corner, please write x plus 3. It'll be helpful later on. Eventually, you can stop writing it. Most books do not write this factor on the bottom. I write it to remind kids that this is the factor. And to make this go to 0, that's going to be negative 3. Now, go ahead. I'm going to give you guys 30 seconds now. 30 seconds on go for you guys to finish this. Let's see if you guys can finish this in less than 30 seconds. I'm sorry. 3, 2, 1, go. Okay, that's 30 seconds. You guys finished, right? Like, you guys probably finished it within 10 seconds. So let's go ahead and try it. Bring it down. That's going to be 1. Multiply up by what? Multiply by negative 3. Negative 3. Bring it down becomes 9. Multiply by negative 3 becomes negative 27. And we are 0. Okay, what's left over? X plus 9. So the answer here is x plus 9. Now, I want to make sure this is true. Whenever you divide something, let me show you the basic concept. If I say 10 divided by 2 is 5, right? To double check, we say, hey, that's double check. If I multiply what we divided by over again is 5 times 2, 10. That's double check. Here is x plus 9 times x plus 3. What we divided by, actually my original answer, x squared. 9 and 3 become 12x. And 9 times 3 is 27. Yes, this is it. That was correct. Okay, so hopefully you are believers in synthetic division right now. There are some flaws in synthetic division, and we'll get to those flaws a little bit later. Another day. Plus 9. And that's it. Submit. Okay, now we're going to see a problem here, for example, that this will not divide nicely. And I can tell you that I guarantee it won't divide nicely, because look at the numbers 4 in the back over here, sorry. Look at the numbers 4 and the number 26. Does 4 and 26 divide nicely? No, they end up with a remainder, so we know we're going to end up with a remainder here for sure. So let's go ahead and do this problem. Okay, so why don't you guys right now set up the problem in synthetic division for me. Oops. I thought I clicked it. Why don't you set up the problem for synthetic division and try this yourselves and see if it takes you that much time. Okay. So when you guys take the test, you guys are going to have to show me this work, right? When I see your work, I better see you guys doing synthetic division like this. Exactly my method. Exactly my method. In this case, we will have a remainder. I'm seeing a positive 10 as a remainder. Okay. Now, how do I rewrite this out? So let me show you a reminder from back in the day. If I said 10 divided by 3, 3 goes into 10 3 times with a remainder 1, right? And we write it this way, where we write what we try to divide by over the remainder, under the remainder. So we're going to do the same here. We're going to rewrite this as x minus 4, this time plus 10 divided by x minus 4. And this is how our answer is going to be written. I tried to divide 10, didn't work, we have a remainder, so we're stuck with it. All right, so x minus 4 plus 10 divided by x minus 4. We tried to divide, it just didn't work out. Now, that's our answer, but I want to show you, is this true? Is this a true fact? Let's go ahead and do something kind of awkward, okay? This is going to be awkward for you guys. I know it's going to be awkward. But please take a look at what I'm going to do here. I'm going to actually multiply them back together again to see if we get our original answer. We're going to multiply x by x, okay? We're going to multiply everything to the front. And then I'm going to save the back for a little bit. So if we multiply the front, it'll be x squared minus 8x plus 16. Okay. And if I multiply this by the fraction, do you see how they have the same denominator? X minus 4 divided by x minus 4, let's leave me a 10, right? So we're left with x squared minus 8x plus 26, which is our original problem. Just say this is the answer. This is what it looks like. That's my remainder. Okay, so how do you write this in Desmos? Or in IXL, whoops, in IXL. How do I write this in IXL? Let's see if I can remember this. We said it's going to be x oops, x, what do we say, x minus 4 or something? X minus 4. Darn it, I should wrote that down. X minus 4, then plus, and we're right using fractions, 10 divided by x minus 4. All right. So I wrote my polynomial in the front, followed by my fraction in the back. Let's see if this works. Terrific. That was it. Now, when they write division in this form, it's just like what we talked about before. It's just a different format. So this is the last problem I'll do. So I'm going to do synthetic division. Here we go. What are we dividing by? That goes on top. And we're dividing by x plus 2. On top, we're just going to write the numbers 1, 6, 7, and negative 40. Again, these are placeholders, x cubed, x squared, x, and constant. Now, for a problem, if I give you a problem that looks something like this, x squared, so x cubed plus x plus 3. If you notice here, I'm missing an x squared, right? So for problems like this, you would have to include a 0 as a placeholder. Take a look. Since I'm missing x squared, I'm going to have a placeholder for x squared. So this is a side note. If you ever have a missing value, you have to put a 0 there as a placeholder. Okay, I'm going to use negative 2 up here as my key. 1, negative 2, 4, negative 8, negative 1, positive 2. Oh no, it didn't work. Negative 38. That looks like my remainder. Let me double check. 1. Sometimes you might copy it incorrectly. Sometimes I do that. 1, negative 2, 4, negative 8, negative 1. Yep. Unfortunately, that's it. We have a remainder here. So we're going to write x squared plus 4x minus 1 plus, wait, that's a negative actually here. That's negative. So we're doing a negative minus 38 over x plus 2. And that's our answer. Okay. So that's synthetic division in a nutshell on the easy problems. We'll work with the application of what we will be doing with synthetic division to factor out large order polynomials next time. Okay. All right.